Hello and welcome back to your friendly physicist and other nerds. Today's episode is a special one because we are not in a studio. We are actually more or less live at the Paul Scherrer Institute, the PSI, in Switzerland, and we are right next to a neutron beamline. And if you're new to this, a neutron beamline is basically a huge scientific instrument that lets us shoot neutrons at materials, our samples, to watch what happens inside them. Right now we are using it to study cellulose, which you probably know from paper making, packaging, and a lot of other cool stuff. I'm not alone here. Joining me is my colleague Saul, who is sharing this Beamtime adventure with me. Now, Saul is a PhD student from KTH Stockholm, and we are working together since now 2 years, roughly. We're doing both cellulose research. And we thought, instead of just telling you about our work, we wanted to ask you to send in some questions about beamtimes. So what is actually a beamtime? How do you get one? And why are we actually doing this? So why are we going to PSI, to here, or other facilities in France, the UK, or even Australia with a lot of equipment just to spend day and night shooting neutrons or X-rays on our samples? And you delivered quite well, so we got a pretty nice selection of interesting questions. Thank you for this. We really hope our answers and Beamtime stories might provide some values or are at least entertaining. And before we start, welcome Saul, and thank you very much for joining me on this spontaneous episode. It's always a pleasure to have people around who are up for doing something like this. So welcome and thank you.
Thank you for inviting me. But then let's get to it.
Yeah,
Right?
absolutely. Obvious first question: what is a Beamtime? So, what is a Beamtime for you?
So for me, Beamtime is an experiment, a very complex experiment, or very not very complex sometimes, but a very expensive one to put it in some words. So it's a very specific one that we apply for, and there is a lot of competition. So getting it is really great, and it's a very good opportunity to measure your samples in a different way that you couldn't do in your lab.
Yeah, the most important point is you apply for a Beamtime when you want to measure at an instrument that you don't have readily available in your basement or in your home lab. So you have to go there actually to make use of this instrument. How do you get access to these instruments was another question. I think you halfway explained it already.
Yeah. So basically, there is this proposal-based system, and there is a peer review system. One should write the proposal, and then there is a committee that evaluates the proposals and actually rank them in a certain way that the scientific relevance is the most important. There are, of course, other different categories or requirements that you need to fulfill, and that gives you a score. And then if you go over the threshold, you get the experiment. If you don't get it.
The main thing here is, I think, that the threshold you have to exceed is not a fixed value.
Okay.
Because if you have a very strong proposal round with a lot of very good proposals, then you might be over the threshold, but 3 other proposals are even ranked higher, and then you still don't get the Beamtime. But basically, you write a proposal, you apply for Beamtime, and if you convince the peer reviewers, then you get to have Beamtime. And I think one of the things that at least I underestimated massively in the beginning was how long it takes you from writing a proposal to actually measuring the experiment you proposed for. So when I started my PhD, I had directly Beamtime the second week of my PhD, but of course this was not a proposal that I submitted, but there was a proposal a colleague submitted 6 months ago. And that's actually the typical timescale.
Yeah, so for me, I think it's a bit tricky because sometimes you have an idea and then you didn't even start working on it before you submit the proposal. So it's a bit of a work if you want to do it in a sustainable way that you don't have to wait that long. You need to think of what you're going to do a bit before, submit the proposal, and then work a bit on the go of what you want to achieve when you do the measurement.
Ideally, you do it even the other way around. You work on the proposal, then you get preliminary results with complementary techniques you have in your home laboratory. This goes into the proposal, then you can submit it, and then 9 months later you can actually measure it. And then you have only measured it. You haven't analyzed anything. You haven't written it into a manuscript. So just from the times, imagine being a bachelor student or a master student with having 12 months time to do a master thesis. Having an own proposal, like an own derived idea, is quite challenging, I would say.
Yeah, even for PhDs,
Yeah,
I think
even
it's
for PhDs.
it's a very challenging thing to do.
So the stakes are high once you get Beamtime, and you don't want to mess it up.
No, not at all.
When you are in a neutron facility, and this is the next question: how does it look like in a neutron facility? How does it look like at PSI for you?
For me, it looks like a factory.
Yeah.
Let's put it that way, or that's the closest thing I can think of. So you have this big holes in which you have all the machinery in, and at the end of the day, when you enter, it's a bit more or less like a factory where you have the machines and the people. Of course, the structure is a bit different because you have the reactor in the middle, and then you have these different parts where you get all the instruments surrounding it. But of course, yeah, it varies according to facility.
I think all facilities look more or less the same.
Yeah, but I was talking about the structuring because sometimes they prolong the holes very long. I mean, it really depends. Here, it's a very compact scenery, in my opinion, from what I've seen in other facilities. But yeah, more or less, it looks pretty much the same.
It looks like a mixture of a factory, a lab,
like an industrial park.
Industrial park, yeah, more or less. But I like it. When I had my first Beamtime at FRM in Munich, I went in there and was like, okay, I want to spend time here. It's a bit freaky because I don't know. It has a soothing effect on me.
I mean, I think last night when I was coming back to the guest house in the middle of the night, I thought this is the perfect scene for a horror movie.
Yeah, okay.
Because I was all alone, just going back. But yeah, of course, I guess it depends on the on the day, or if it's day or night, or the time that you are in.
That's true. Yeah, in the night it can be a bit sketchy. That's true. So typically a facility is then embedded in like a larger scientific infrastructure. So you have also other labs and other facilities, research institutes, maybe a university nearby, but then also restaurants, a guest house where to sleep.
Or not.
Or not, yeah. That would be another question. How long do you usually stay at the beamline? And do you sleep there? You stay at the beamline as long as it takes. So once you have Beamtime, typically you apply for a couple of days. So my Beamtimes are usually between 3 and 5 days. 5 days is already long. Now here at PSI, we are in total for 11 days,
yes,
which is super long. But to be honest, no one of our Beamtime team stayed the entire time. So we distribute the days a little bit. But yeah, shifts can be long.
Yeah, I guess it really depends on the type of experiment that you're running. Sometimes experiments don't require attention from you, and you get certain parameters that you get set, and then you start measuring. In general, neutrons take a pretty long time to see results, or like to scatter in this case. So you need to measure several times, and that requires a long time. But basically, if you have an experiment like the one we are having now, for example, we need to regularly check relative humidity because we are working with that, and also temperature. So I guess you stay as long as it's needed. It's said by the experiment. And regarding sleeping hours, we normally come in teams, so we have shifts, and then some people can take care of the night and some people can take care of the day. But yeah, we don't try not to sleep on Hajj.
It happened. It was a Beamtime at ILL with a cooperation partner, also from Stockholm, from KTH, with Erik. It was a very nice Beamtime, but it was only the two of us, and it was a mixture of reflectivity and Kisans, and we had so much to prepare in the chemistry lab for every measurement. So one of us was measuring, the other one was in the lab cleaning and preparing next sample. We want to make use of as much Beamtime as possible, of course, and I think the shift was 48 hours. The local contact waked us up in the morning because we
No.
were both asleep in the hutch of the Figaro instrument that I led. That was it was
Memorable.
memorable. Yeah. Beamtimes are also great opportunities to bond with colleagues.
Yes, yes,
And with the
definitely.
scattering community.
Definitely, yes.
Do you actually see the neutrons? Have you ever seen a neutron?
No, unfortunately, I haven't.
Not by eye, no.
No, not by eye, really. But it would be fun.
Very fun. Yeah. Every instrument has a detector. The detector makes the neutrons visible, but in an indirect way, the neutron is causing an electric signal, and the electric signal is then visible as a tiny pixel that changes the color on your screen, and then you know, okay, there we have detected a neutron. Another question would be, what is the food situation? What do you do during, or what do you eat and drink during night shifts? Are there only vending machines, or are there also like proper restaurants?
This is also very dependent facility to facility, of course. I would say most of them have a sort of a canteen or a place where you can buy food. They have, of course, working hours. So if you're in a very weird working hours or weekends, sometimes also they don't offer food in the weekends. I guess we would have our friends, the deliveries, or yeah, vending machines. I guess something like this should work. Also, supermarket, you go before the beam time to the supermarket to stock yourself from sufficient snacks and food in general.
Yeah, this is what I learned during the years. Whenever you have time, go to the supermarket, stock up on snacks and instant coffee.
Yes,
brings me through the nights. Usually, there is nothing more frustrating than being stuck on a beam line. Nothing is working. You don't reach your local contact. No other users are there that can help you, and then you don't even have a snack or a coffee or something.
yes. But I think there is something important to say here is that if you're in a neutron facility, like eating is not allowed in the hutch, so you need to go out.
No eating and drinking in neutron facilities. Why doing neutrons, not X-rays?
Well, we can see different things with neutrons and with X-rays.
Yeah, this is a question I get asked very often, and I would say it's not a matter neutron or X-rays. It's a matter of doing both.
Yes,
so neutrons
yes.
and X-rays see different things.
You get the full picture with both of them.
Yeah, different energy scales, different wavelengths. There are two types of personalities.
Yes.
Neutrons are very slow, but insightful. X-rays is
fast and furious.
Fast and furious. The chatty thing that gives you information quickly.
Yes.
Yeah.
So one is more cautious and the other one is in hurry.
What do you like more? What do you like
better? I like them both, of course. I mean, they serve different purposes. In general, I would rather a beam time with neutrons because you get more realistic night sleep and like realistic time of like you can do other things surrounding it. You can go for lunch. You don't have to eat in the hutch. But I guess that's something X-rays, as you're allowed to eat in the hutch, you would end up doing it. So I would rather neutrons. What about you, Lucas?
I agree. I'm a neutron guy. I had, I think, two X-ray beam times so far. So I'm a total X-ray noob, and I like neutron. I like that it takes time. You have to adapt often. So usually I come with a measurement plan, and then the measurement plan has to be readjusted several times throughout the beam time. I like to do this. I like the community. I think the neutron community is much smaller than the X-ray community, or at least this is my impression. I just like neutrons. How do you stay awake for a 3 a.m. sample change? This is a nice question because Sol had a 3 a.m. sample change.
Literally last night, yes. So I was feeding some data. So I did a little bit of a break because I had a sample change at 8 and then another at 3 a.m. So, you know, I went to the guest house, had some dinner, and then took a shower, basic stuff you do.
But you stayed awake until 3 a.m.
Yes, I was awake, and at around midnight I went to the hutch and I was fitting some data.
Okay.
And then I watch a series, because you can catch up on series as well.
Yeah, that's true.
if you don't have any more brain left,
Yeah.
you can also enjoy a book or a series or a movie or something like this. I was all alone in the hutch, and there was literally no one in the hall, so it was a nice opportunity.
3 a.m. is a threshold time for me.
Yeah, so if it's more, you sleep.
3 a.m. would already be so late into the night that I would sleep before and wake up at 2:30 and then go to do the sample change and do whatever is needed, and then you come back at 4 a.m. or so, and then I would sleep again.
For me, I think 3 is the threshold in which I don't sleep, because if I would sleep there at 11 or something, then it would be less than 4 hours. And in that case, I don't work. And my brain doesn't work. So for me, it's a bit, that's the threshold. If it would be 4, I would have slept.
Yeah.
But 3 is the break point.
Yeah. Maybe you are 1 hour apart.
Yes.
What is the weirdest thing that happened to you on a Beamtime?
What didn't happen on a Beamtime?
What didn't happen?
That's the question. The weird things happen all the time, but let me think of the weirdest.
It's actually good. It's a good question.
It's a very good question, but also I feel that what I find weird may not be weird for some of the people, and vice versa. So I mean, we can say what we are doing here. For example, in the first night, we set up everything, we start measuring, and we said,
maybe you can quickly explain your experiment.
Yes.
What you're doing.
Yes, of course. So right now I produce films with different techniques, cellulose films, and basically what we do is subject them to different relative humidities, and we measure with neutrons, or we are trying to measure diffusion of water in the films.
Why do you do this? Why should I care?
Because we use paper in our lives, daily lives, and if we can dry it faster, we would get cheaper paper, for example, and that involves a lot of different sides of our life. My PhD is about cellulose dehydration, or more effective ways of dehydrating cellulose, and that plays a huge role, not only for the paper industry that we know, but also for more new and costly applications that we could do to cellulose, like medicine or like drug delivery or different things. If we can stabilize cellulose in a humid environment, we could potentially use it for many more things than just paper.
Cellulose.
Cellulose
is super material. And when I was in high school, I had in Germany it's called Facharbeit. You have to do shortly before you do your high school graduation, and it was about cellulose.
Oh, nice.
So when I was like 16 years old, that was my first longer project. It
was your destiny.
Yeah, apparently. What was the question? What is the weirdest thing?
The weirdest thing. Basically, you need to improvise something called shielding. That is, so we get the nutrients that come from our sample alone and not from the whole environment. And this shielding is there, and we taped it because it's an improvised setup.
Duct tape is your best friend.
Yes, but it fell off the first night, and we lost like 8 hours of measurement just because the thing fell off.
Damn.
Yes, it was a bit bad.
Yeah, Beamtime is also a good training for your inner resilience.
Yeah, but I had some other thing that was I almost had a heart attack. But we were doing an X-ray experiment, and suddenly I started getting some weird images. I was like, well, something is wrong, something is off. And I was like to my team, like my other team member, I was like, could you check if everything is all right inside the hutch? And this person was like, yeah, sure. And they came back and it's like, maybe you wanna take a look at this. And I was like, okay, what happened? And I entered and I see a mark on the detector. We are talking about millions of euros. Like it's a very sensitive equipment, very expensive. Yeah. And I was like, oh my God, we should call the beamline scientist. So we called him, and he was acting totally normal, right? And I was like, what's this mark? I mean, did we do it? And suddenly he was like, I don't know, this was done by another user. And I was like, oh my God, I almost thought I just broke a detector, which is worth millions.
Yeah.
And he was like, oh, no, this was done by someone else. And I was like, that would be nice that you should have mentioned this before. It was just, this is such a costly equipment that also when you manage it, it's a lot of responsibility to take care of it.
Absolutely. The local contacts, so the people working at the instrument and support you during your measurements, are a special kind of people, I would say. Another funny thing we did during one of the night shifts at ILL, it was at D17. We had to wait for the measurement, and it was my colleague Toby and me. We were bored, and we played around with the camera. So there was a camera, so you can actually, so you sit in the office next to the instrument, because the instrument has to be closed because there's the neutrons and radiation. But there is a camera focusing on the place where your sample is. So you can actually see the sample on the computer in your office. And you can move the camera, and you could move it so you see the entire hall where all the instruments are. And I said to Toby, hey, maybe you can hide somewhere in the hall so that you can still see the camera. So I know that the camera could potentially also see you, and I look for you on the screen because you can also zoom and stuff. And when I think I found you, I text you on WhatsApp, and then you said, no, that's not me, or yes, that's me. And we did this for 5 hours.
Wow, okay.
And it was, Toby was hiding, then I was hiding. We did turns. That was so fun. There was
That's so much fun.
That was really fun, yeah. That was a nice time, nice Beamtime. 17. Next question. How long until you know the experiment worked? 10, I would say.
Yes, it really depends. It depends on what you want to measure, because sometimes it's pretty visible, but sometimes it's not. Yeah, sometimes the differences are so subtle that you might not reach them in the experiment time, even if you are aiming for it. Sometimes it doesn't happen.
So usually when you go to a facility and you have to do all this proposal stuff and all this high effort to do an actual measurement, typically you're not doing like a standard experiment. At least I don't do this, or I try not to do this. I always try to have a good balance between a risky experiment that could fail easily, but if it works, it's also super nice and you get really nice results and insights into your material. And of course, you try to analyze your data as much as possible while measuring. So I would say typically you have at least a feeling if it went well or if it didn't went well. But the actual analysis can be quite time consuming, meaning months.
Yes, definitely. Not to talk even about the paper coming out of it.
Yeah, so do the measurement and then the analysis a couple of months, and then the writing or the manuscript, submitting it, reviews. So from coming up with an idea to actually publishing this, easily 1.5 to 2 years.
Yes, I agree.
Yeah. What is the most common way to fail an experiment?
Well, I guess first of all, on our hands, not being prepared.
Yeah.
That is our homework, let's say. Of course, if you're not properly prepared, that can cause the failure of the experiment. Then there are a lot of things that you cannot account for before doing the experiment. So you get the insights while you are doing the experiment, because there are a lot of things you cannot predict. So that is also another way to fail an experiment.
This is out of your hand, I would say.
Of course. So in our hands, preparation, I think that's the best we can do to prevent any failure.
Yeah.
But then, of course, there are things that come from the facility, because we might not have neutrons, for example, and then
just like we had the last 3 days.
Yeah, so we might not have neutrons, and there's nothing we can do about that.
Yeah.
Also, something that comes up with the experiment, like the shielding falling, that's something also we cannot predict. We thought it was going to stay in place.
Yeah. I have a positive example for this. When I was at there was another Beamtime at D17 at ILL, and we have been there with a new bunch of PhD students, in particular Christina. And Christina was or is an exceptional good scientist, and she prepared everything to the fullest detail that I was already annoyed before the Beamtime because we had so many meetings and so many checklists and plans and preliminary measurements where I would say it's not needed. And then we went to this Beamtime, and there were so many things from the facility side, from the instrument, changed and failed. But because Christina was so well prepared, we could really quickly adapt to all these changes. And in the end, we measured 3 proposals, even though we actually had only time for 1.
That's great.
I don't know how we managed to measure 3, so 3 batches of samples for Christina, for another colleague, Peji, and for me. And we got 3 papers out of this.
Wow.
And
impressive.
Absolutely impressive. And that was one of that was a key memory for me and on my learning journey during my PhD, that no matter how good you think you are prepared,
no, you can be always more prepared.
You can prepare even better, and it's always worth it, at least if it comes to such a thing like a Beamtime, where it's a high effort but also high reward thing.
Yes, but I also think of like, okay, what could be going wrong, and then you extra prepare for that. Like you prepare extra samples, you make yourself ready for it, because you won't have this time, and another time it's not you cannot access this so easily. So it's worth
absolutely
extra job actually. I'm Team Christina here.
Yeah, me too, absolutely. Christina, if you ever hear this, thank you. Do neutrons damage the samples?
No, they don't.
That's a good thing, yeah.
Yes, that's what we like also about neutrons. They don't interact with our sample as X-rays, and then, like for example, my cellulose films, if we expose them to X-rays for a long time, and they will just burn, they will just carbonize. So neutrons, that doesn't happen with neutrons. We can just measure and measure and measure for hours, and nothing happens.
Neutrons are very gentle to your samples. Don't damage anything. What is the favorite part of a Beamtime?
For me, I really like preparing for a Beamtime.
Yeah?
Yes.
Okay, you really are Team Christina.
I'm really Team Christina here, really. Because I feel that sometimes during the Beamtime you get through a lot of stress, so it's not that enjoyable. Especially if you have like problems in the Beamtime that you need to tackle, so you need to be alert. But I guess when I am preparing for Beamtime, I can enjoy the process. I can just time it and enjoy the process.
Yeah.
What about you?
The first measurement, for sure. So I don't like the preparation too much. So typically the preparation part for me is I make sure that I have enough samples with me coming to a Beamtime, so that if one sample doesn't work, I can always switch to another sample or to another system and measure this. But I understand that a PhD student who is in his final year or second final year cannot do this, because you want to finish and then maybe you have plans for going to industry or something like this. So I'm in a very comfortable situation to have a couple of projects, and if this project doesn't work out, then I focus on another one. But being then here and opening the shutter or press on run the script, and then I see the first scattered neutrons, then in my head,
dopamine.
Progress, measurements coming in, nice. All the insights we get from this. This is a nice feeling.
Definitely.
This I like. I also like the last measurement when it closes a Beamtime, and okay, this was a good last measurement. We got everything we came for. You have a good feeling.
That's true.
One time at the at FRM, we started the last measurement at 10 a.m. or so, and we asked the local contact. It was the very last day of the cycle, and then after that it was the Christmas break, and the reactor was shut down. And we asked the local contact when the reactor is going to shut down, and he said at 2 p.m. And we said, okay, it's 10, so we have 4 hours. It's sufficient time, super nice. We get proper statistics. Start. just let it run until the reactor shuts down, and then we are also finished. And then we came at 2 p.m. and the reactor was already shut down, and asked, yeah, when did they shut down the reactor? It was, yeah, at 10:45. So yeah, only 50 minutes. The statistics were horrible, and the measurement didn't make it also into the publication then afterwards. But we wrote in the main text that due to unforeseen early shutdown of the reactor, we weren't able to measure this measurement. So we had a figure with 3 graphs, and one of the graphs was only halfway, and the second half was missing. But we got it published, so
okay, that's nice.
What was also.
The reviewer was merciful.
Yeah, reviewer said, well, we've all been there. Also, the reactor wanted to, or the people who run the reactor, they also wanted to go to a Christmas break. So no hard feelings there. A fun question: what would be the superpower you wish for the most during a beam time?
For me, maybe not needing to sleep that much. But yeah, we are humans, unfortunately. Yeah. I think that would be for me, like not needing to sleep, or like being fresh without sleep.
Yeah,
maybe that's the superpower.
That's a good one. Yeah. I would wish for 2 more arms. I think, or maybe 4 more arms.
Wow. Okay, spider-like.
Yeah. So usually my beam times involve a lot of equipment, like this chamber and this humidity thing, humidifier, and stuff like this. And typically, neutron instruments are places which are very narrow.
Yes.
Not so much space. I'm not the smallest person. So to have more arms, I would be more bulky, of course, but I think I would also have more possibilities to.
Maybe you could climb.
Yeah. Yeah. Hang from the ceiling, like Spider-Man. I saw a spider in the reactor.
Oh.
Near our instrument. Maybe I can become the next Spider-Man. Don't think this is how it works. Any advice for young scientists who want to apply for a beam time?
My advice would be that they find the person who does this on a regular basis, and that they pair up with them, because that's great. I mean, if you get advice from someone who knows more than you, of course you can do it alone, but the learning curve is pretty steep.
Yeah, that's true.
So yeah, pairing up with someone who does this on a regular basis would be my advice for them.
Would also be my advice. If you have a scientific questions and you say, I want to find out exactly this, then identify the technique with which you can do this. And even if it's a very complicated technique, like a neutron scattering technique or X-ray scattering technique, there are instruments where you can measure this. There are local contacts working there doing this on a regular basis. Usually they are very friendly people. Write them an email or give them a call. They like to share their knowledge with you, and then you can write a proposal together. Do a first easy, in quotation mark, experiment. And then let's see where the journey leads you. What would be your dream experiment? Last question.
That's a tough one. I don't know if I would have a dream experiment, but maybe a dream outcome.
Yeah.
So I would really like to have a breakthrough in science on one of my experiments. So it's not more about the place or what you're doing, but like the results. That would be maybe my dream.
Hunting the Heureka moment.
Yes.
I had a Heureka moment at DC one
Oh,
time.
nice.
We did wax sucks on metal melts, and the suck signal was looking super weird at one point. And we were like, whoa, 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 what's happening? What's happening?
No.
6 people staring at screens. It looked like a quasi-crystal that you know from a polymer solution or something like this. We didn't know what it was, and I still don't know it because I'm not working in the field anymore. So maybe I should give them a call. What
was that?
Or if it just, often these Heureka moments are just like, there's some weird thing accidentally hanging in the beam.
Yeah, of course.
And it's not your sample actually, but
reproducibility.
Yeah. Another cool moment was when I measured for the first time these cellulose films. You're also measuring with Quens, and I got the first spectrum, and it proved my point. And I saw it, and I was like, yes, it works.
Yes,
It works. And because this was like, okay, I can continue like the stuff I'm doing for the last 1.5 years.
But do you still have a place? Because a place or some experiments you would, it's like your dream experiment because you've done so much.
This kind of stuff.
Mm.
I don't know, a dream experiment. I would like to do an experiment in space because that would mean I would be in space.
Okay. But you want to take a reactor out of
Maybe an X-ray source.
Okay.
It's easier. The setup we are using with the Raman and the stuff, so coupling two measurement techniques together is always something I like to do. Actually, I wanted to have an FTIR, not a Raman, but I mean,
Yeah, sometimes.
who am I?
Yeah.
This is what I want to do with Daniel, building the same chamber but with an FTIR. So I will get it at some point, and then doing experiments with this. With this, I like that it's of use for others because it's a sample equipment that is not available by default at neutron sources or X-ray sources. Now we publish the paper about this equipment, and people read this and they say this is of interest also for my system, and they come to me, and then we can do experiments together, which means more beam time or nice stories.
Yeah, of
I
course.
like beam time. Thank you.
Thank you
For sharing your Beamtime experiences and some funny thoughts about superpowers and your weirdest things on Beamtimes. It was fun talking to you. It was fun measuring with you. Do we go to Stockholm now?
Yes, I will go to Stockholm now. Thank you very much.
And probably see you around at KTH
in the
or
next experiment.
Another neutron X-ray facility.
Yes,
cool.
Definitely.
All right, thanks.
Thank you.
And that's a wrap on today's episode. Now Saul will go back to Stockholm and I will continue measuring our cellulose samples. But if you can't get enough of scattering content, you might want to check out the episode on small angle X-ray scattering with Brian. I think it's episode 23. If you liked this one, feel free to share it with your friends and follow this podcast. Thanks for tuning in and see you soon on the next episode.